Welcome to the Tutor TipVid on section 5, quantum gates and algorithms. And what I'm going to show you here is how we can do a very, very basic quantum gate circuit. And I'll do this from the IBM Q experience. And all it is a NotGate. But I'm going to show you how the matrices are lying behind the gates. And then I'm going to show you how you multiply it together. I'm going to prove to you that by having a qubit initialized to 0 and applying a NOT gate, how that will make it 1. Okay, let's go. I'm going to get onto the IBM Q experience. When you log on, this is what you come up with, and you just enter your details in. And I did it, and what I did was I dragged down a couple of these gates. So if you look in the middle of the screen, you can see that I've got a qubit, my qubit 0, the horizontal lines are qubits. And I place it's initialized to 0. It always is. Almost every algorithm starts that way. And all I've done is put a NOT gate and measured it. So you may see that by putting on this NOT gate, it's saying that the first qubit is in stage 1 with 100% probability, which is what you would expect. Now look, if I wanted to, and if I was live on the Q experience, I would merely click this button, set up and run, and then I can choose to do it from a simulator or an actual quantum computer. And here again, I'm just showing you exactly where it's saying it's 100% 1. But I want to show you what's happening in the background. So the quantum gates, you may remember we've got the XGate, and that's up the top here. And you can see the matrix is a 2 by 2 matrix, 0, 1, 1, 0. And that will always flip whatever state the qubit is in. And I'm going to prove that to you. So here we are with the we're applying an XGate to a 0 state. The XGate is how I just said it to you, 0, 1, 1, 0. And the 0 state is represented by what we call a column vector. So what is the result if we multiply them together? Well, I'll show you. Okay, so what we have is the NOT gate. And remember, this was 0, 1, 1, 0. And the qubit is initialized to 0, which we show as a column vector, which we show as a column vector 1, 0. So now we have to multiply these together. Well, can we? And if we remember that this is a 2 by 2, rows before columns, Darcy, D-A-R-C, R before the C, rows before the columns, and a 2 by 1. And the beauty of that is that the inside numbers have to be the same, and they are. So that's wonderful. So we know that we can multiply these two matrices together. Now we want to know what will the dimensions of the final result be. And that again is we have a 2 by 2, a 2 by 1. And in this case, we take the outer numbers, and they don't have to be the same, but they're showing that the final matrix has to be, in this case, a column vector, a 2 by 1 column vector. And of course, if a NOT gate it's doing its job, it's going to be a 1, and it's going to end up like this. But let's see if it does. Okay, so let's now actually multiply them together. And of course, what we do is you multiply the first row by the column, and then we put that into the result. So we have 0 times 1 plus 1 times 0, which is 0 plus 0, which is 0. And then we now do the second row by the column, and that equals, I'll just do that over here, that equals 1 by 1, which is 1, then 0 by 0, which is 0, add them together and you get 1. So indeed, the mathematics stacks up. We have flipped the qubit. Fantastic. Well, I hope you've enjoyed this tutor tip vid, and I'll see you in the next section. Thank you.